For those who've never watched it, cricket is a game that can be somewhat compared with baseball, with a few changes. It's played on a large oval field, with the pitch in the centre. The batting players aim to score runs by hitting the ball and running between the ends of the pitch as many times as possible before the fielding team can return the ball. This video will outline 3 biomechanical principles related to cricket, including projectile motion, pressure drag, and impulse. A batter can score 6 points for their team by hitting the ball over the boundary on the full. Here we will look at whether a certain hit will go for 6. A typical cricket oval is about 140 metres long, the distance between the wickets is 20 metres, the pitch is in the centre of the oval, and the batting crease is marked 1 metre in front of the wickets. Therefore, the distance from the batsman to the boundary is 79 metres. Let's assume the batter hits the ball 35 degrees above the horizontal, with an initial velocity of 30 metres per second. From this we can determine the horizontal and vertical initial velocity components, and subsequently calculate the time in the air. We know that the horizontal acceleration is 0, and that vertical acceleration due to gravity is negative 9.81 meters per second squared. We can use the vertical velocity and acceleration components, along with the formula final velocity equals initial velocity plus acceleration by time, to determine the time from initial contact to the ball's maximum height, which turns out to be 1.75 seconds. Because gravitational acceleration is constant, the ball will take the same time to reach the ground from the max height, making the total flight time 3.5 seconds. We can then use this time value along with the horizontal velocity component with the formula displacement equals velocity by time to find a total flight distance of 86 meters, which means the ball will clear the 79 meter boundary for 6 points. But let's make things interesting. Let's put a fielder right on the boundary who can reach up to 3 meters in the air when jumping. Can he catch the ball before it crosses the boundary? The time that the ball reaches the fielder's horizontal position can be calculated as 3.22 seconds. To find the height of the ball at this time, we can use the following equation. The calculations confirm that the ball will be 4.56 meters high at this point, so the fielder will not be able to catch it and the batter will still score his runs. Many professional fast bowlers have the ability to cause the ball to swing mid-flight. This is somewhat similar to a curveball in baseball, however the underlying physics is quite different. In a cricket match, a bowling team that wishes to use swing bowling will continually shine one half of the ball on their pants, leaving the other side rough. When travelling through the air, the smooth side causes more laminar flow of the air, which increases the airspeed relative to the ball and decreases the pressure on that side. The rough side causes turbulent flow, leading to a reduced airspeed and increased pressure on that side. The greater pressure on the rough side forces the ball in the direction of the smooth side. When this method of bowling is used effectively, it can have extremely successful results. When attempting to catch a ball, fielders often move their arms back quickly as the ball reaches their hands. This is an attempt to minimize the force of the ball on the hand. Suppose a ball, which weighs 0.16 kilos, has a velocity of 30 meters per second upon impact with the hand. No matter how the bowler catches the ball, the impulse will be equal, as the ball's mass and initial and final velocities will be the same. However, the average force applied to the hand over time will be quite different. If the fielder barely moves his hand when he catches it, the ball will have a very fast deceleration over a short period of time, for example 0.1 seconds. The average acceleration over the period can be calculated with the formula acceleration equals change in velocity over time. In this case, the ball will decelerate at 300 meters per second squared. As force is equal to mass times acceleration, the average force applied will be 48 newtons. This may not seem like much, but applying this force continuously over a 20-year career is likely to cause damage to the soft tissue and bones of the hand. If the fielder pulls his hand back upon contact with the ball, the deceleration will be slower, and over a longer period of time, for example 0.5 seconds. In this case, the average deceleration will be 60 meters per second squared, leading to an average force of only 9.6 newtons on the hand. This is much less likely to cause injury over an extended period of time.